Go ahead and pull your notes up for 1-5. I will do this in 2 parts, guys. We're talking about combination of functions, and then we're going to talk about composition of functions. What does it mean? What does the word combination mean? When you have a combination, or when you combine, what does that mean?
You're putting them together.
Putting together. That's it. This first part is literally combining like terms. Adding, subtracting, multiplying, dividing, polynomials. You guys have seen this a gajillion times. The second part, the next page, is called compositions of functions. And that's written like this. Like it'll say, my pen will work. F of G of X. That doesn't say fog. That doesn't mean to multiply. A composition of a function is when you take one entire function and plug it into the other one. And we'll do that tomorrow. We're going to do this in 2 parts. I'm going to give you guys your quizzes back at the end of the class period today so you can ask questions and stuff. But when we talk about combining functions, you're going to do it arithmetically, by arithmetic. If you are adding 2 functions together, all you're doing is basically combining like terms, correct? You will be given 2 functions, maybe 3, maybe 4. Here they gave us f function and the g function. And they told me right here that I'm adding them together. How did I know I was adding them together? Because there's a plus sign, correct? So you just write the function out, you combine like terms. When we subtract functions, what's something you have to remember when you subtract functions? What's right here? You got to distribute that negative, right? It's really important, guys, that you remember little tiny things because a little mistake makes a huge difference. Some of you on your quiz, when you use your quizzes back, please do not get your quiz and say, oh, I'm so stupid. I hate when you guys do that. None of you are stupid. Do we make silly mistakes on some things? Yes. At some people, 17 plus 3. What is 17 plus 3? 20. I had some people wrote 14. 14 divided by 2, they got 7. That is true. 14 divided by 2 is 7, but 17 plus 3 is 20, and then 20 divided by 2 is 10. So little stuff like that, you just have to pay attention to, because those little details make a really big difference in the answer. If you look here, what are they asking me to do with f and g? Multiply. So you're just foiling. Combine like terms. And then what is this last thing asking us to do? Divide. And then here you will have a domain restriction on some things. Why is there a domain restriction on division but not on anything else? Because there's an x in where? The denominator. And your denominator cannot be 0. So you're going to be asked these questions in 2 different ways. You're going to be asked to leave your answer in terms of x, like all of these are here. They have x's in their answers. Or you're going to be asked to evaluate using a number. And we'll show you that. Another way that your addition, subtraction, all that stuff can be written is like this. Do you notice how this parenthesis just has f plus g of x? It's the same thing as f of x plus g of x. They just write everything in one parenthesis and then put the x on the outside. Do you guys see that? Okay, means the same thing, so don't get confused. So you will have a question on your test, or 2. You'll have some on your homework tonight on WebAssign. And it'll give you functions, and it'll say to evaluate it one way and then evaluate it another way. All right, let me show you what I mean. I'm going to rewrite these 2 functions. Whoops. I'm going to rewrite these 2 functions just so I don't have all these words with it. 2x plus 1. And my g of x is x squared plus 2x minus 1. Now, I'm going to say a is here. And then I'm going to do b over here. Okay, do you guys see a and b? These are 2 different questions. What do you notice is different about a and b? Say it again. B is asking you to plug in 2, and A is saying leave your answer in terms of x. It's not telling you to plug in an x. What A is saying is just add the two functions together. Your answer should have x's in them. B is saying add the two functions together, and then everywhere you see an x, plug in a what? A 2. So in letter A, when you are leaving your answer in terms of x, that means you should have an x in your answer. If you have something like this on WebAssign tonight, make sure your x is lowercase. Letter B is saying, I need a numerical answer. So the way that you would do something like this, you take your f function, 2x plus 1, plus you take your g function, x squared plus 2x minus 1. All right, there is a plus sign in between these two parentheses. So does that mean I have to distribute anything? No, so just combine like terms. What's the highest exponent you see? X squared, so you have an x squared. And I have a 2x here and a 2x here, so plus 4x. What happens with a positive 1 and a negative 1? They cancel. So if your question was asked just like letter A, where it says f plus g of x, that would be your answer. All right. If you're asked to combine the functions, add, subtract, multiply, divide, and plug in a number, then this is how we would do it in B. Now, I know you guys can see that this is what the combination is, but this is if you didn't already do that, I would tell you guys to do this. So my f function is 2x plus 1. My g function is x squared plus 2x minus 1. All right, you can, from this point, you can do one of two things. I personally like to combine the function first and then plug the number in for x. Some of you want to just go ahead right here and replace every x with the number 2. That's fine as well. However you want to do it. You can do it just like this. You can say, okay, in my first parenthesis, I have 2 times 2 plus 1, right? Plus, and then I have 2 squared plus 2 times 2 minus 1. So, yep. Yeah, I'm just showing you. What's 2 squared? No, sorry, it's 2 times 2. Plus 1 is, so 5, plus 2 squared is 4, plus 4 minus 1. What's 4 plus 4? Minus 1. So my answer here is 12. So do you guys see? You added both functions together, but in letter A, we kept it in terms of x, and in letter B, we actually evaluated with the number 2. If you would have combined for B, if you would have combined the function first and then plugged in 2, watch, what's 2 squared plus 4 times 2? What's 2 squared? 4 plus 8 is 12, same answer? So like I said, whatever you guys are most comfortable with. Just, I beg of you, please pay attention to signs. Pay attention to little things. Like an example 2 is over here, correct? They gave us the same functions. F of x, 2x plus 1. G of x, x squared plus 2x minus 1. How is this question different? It's subtraction. All right, this changes the game a little bit. Why does this change a little bit? Now you have to distribute a negative sign. This is why I think it's best to combine your function first. I have my f function, which is 2x plus 1, minus my g function, which is x squared plus 2x minus 1. I can't just combine like terms now because I have a negative 1 right here, and I have to remember to distribute that to everything in that second parenthesis. So this becomes 2x plus 1 minus x squared minus 2x, and then what? Plus 1. So now when we combine like terms, guys, what's your highest exponent? Squared, right? So I have negative x squared. What happens with a positive 2x and a negative 2x? Ooh, they cancel, and then 1 plus 1 is 2. We don't distribute that negative sign, and this is a very different answer than what we would have gotten in the beginning. But I know that I'm leaving my answer in terms of x from the way I wrote the first problem. Why? From the way I wrote up here. How come? Why do I know that there's going to be an x in my answer? Because there's an x in the parenthesis. If they tell you to plug in a number, it would look like this. They say to evaluate here with 2, right? So f minus g of 2. So your f function, 2x plus 1, minus your g function, x squared plus 2x minus 1.
Could we have also plugged the 2 into the answer?
You could also just plug the 2 right there into the answer, which is, in a sense, what I always end up doing. But if I plug in here, so I have in my first parenthesis 2 times 2 plus 1 minus 2 squared plus 2 times 2 minus 1. Well, 2 times, yeah, sure. 2 times 2 is 4 plus 1 is 5 minus 4 plus 4 minus 1. What's 4 plus 4? Minus 1. So 5 minus 7 is negative 2. Very different from other answer. Cassie just said, well, can't I just plug it into what I got originally? Absolutely. I have negative 2 squared plus 2. Well, 2 squared is 4, so negative 4 plus 2 gives me negative 2. Same answer. No problem. But on your test, you'll probably be given one question that says, hey, add these two together and leave it in terms of x. Then your next question says, multiply these two and evaluate using this number. So just so you guys are aware of what the different questions look like. We come over here, finding the product. What does the word product mean? Multiply. So your f function is x squared, and your g function is x minus 3, right? So if I'm going to find in terms of x, that they want us to find first, so f g of x, and then they want me to evaluate where x is 4, f g of 4. I know that in my first, on the left-hand side, it says f times g of x. That means, oh, multiply these together, but leave x in my answer. So my f function is x squared. My g function is x minus 3. Show me that you understand which functions you're talking about, because on your test you'll probably have more than 2. And then what do I do here with my x squared on the outside? We distribute. So this becomes x cubed minus 3x squared, correct? Okay, that's it. Now, if they just give you f times g of 4, you can say, okay, well, my f function is x squared. My g function is x minus 3. And you can just plug in the 4 from the get right here. You can say 4 squared and then 4 minus 3. What's 4 squared? 16. And what's 4 minus 3? Okay, so 16. If you just plugged it into your already combined function, I would say this would be 4 cubed minus 3 times 4 squared. What's 4 cubed? 64 minus 16 times 3 is 48. 64 minus 48 is 16. Same thing. So it just depends on what question they're asking. And I'll do some examples when I'm done with this next example to show you exactly what I mean. All right, let's talk about division here for a second. We're going to have to talk about domain restrictions. You guys have to remember, if you have a square root or something like that, we're talking about real numbers, real answers. You can't have negative underneath the square root, right? Domain restrictions. That can come into play anytime, but a lot of times it comes into play when you're finding the quotient. Because when you find a quotient, what does quotient mean? Division. All right, so if you are given this, I have f of x is the square root of x, and I have g of x is 4 minus x squared. All right, and they want us to divide f divided by g. So when you think about this, it's the f function, f over g. And it says leave it in terms of x. So your f function is the square root of x, and your g function is 4 minus x squared. This part can be a little confusing. First of all, is there anything else I can do to simplify this problem? Can I cancel out any x's or anything like that? Can I say that the x underneath the radical in the numerator cancels out with one of the x's in the denominator? No, you guys can't do that. You can only simplify if it's multiplication and it's something on top and bottom that cancels out. If you have anything that's attached with a minus or a plus sign, like that 4 is stuck with that negative x squared. Did you have a question, Isabel? Okay. So this would be your answer for this problem of dividing these two. But now we have to think about domain. What can x not be? We have domain restrictions here in the numerator and in the denominator. Okay, your denominator, we cannot have 0 in our denominator. So let's talk about the numerator right now. Let's talk about domain. What is the domain? What can you use for x in your numerator? Now this, sometimes you guys are like, oh God, I can't, this is hard to figure out. Start with negatives. Just pick a negative number. -4. Can I take the square root of -4 and get a real answer? You can't take the square root of a negative number and get a real answer, can you? So what do we have to start with? 0. Can I use any positive number? Yeah. It may not be a pretty square root, but I can use it. Can I use 0? What's the square root of 0? 0. Yeah, I can use 0. That's fine. So my domain restriction for my numerator is it has to be 0 or bigger to get a real answer. So let's talk about the domain of the denominator. I see a square root, so I'm like, uh-oh, can't it be what? As soon as you see a square root, then you can't take the square root of a negative number. Okay, so that's something in my mind. I also see an x squared. What happens when you square a negative number? Becomes positive, right? So let's just think about this for a second. All right, what happens if I plug in 0? 0 squared is? 0. And then 4 minus 0? Okay, so 0 will work, right? All right, let's do something on the negative side then. What about -1? What's -1 squared? So 4 minus 1, 3. That works, right? All right, what about -2? -2 squared is 4. 4 minus 4 is
0.
Wait, that one's not going to work, is it? Okay. So I can use anything up to -2. Okay, I agree. I can use -2. Can I use -2 though? No. Can I use -1.999999999? Yes, but I can't use -2. All right. So anything bigger, if I use, what happens with -3? It's going to be negative, so that's not going to work. Okay, so I can't use anything smaller than -2. So let's go to the other side. We said 0 works, right? What happens if I plug in +1? It's still fine. What about if I plug in +2? What happens when I plug in +2? It doesn't work because then, so I can use anything from -2 to +2, but I can't use those two numbers, right? You guys agree with me? Okay. I know this is a little, you gotta think a little bit. So now you're like, okay, big deal. This doesn't happen all the time, but when you have domain restrictions in the numerator and the denominator, you have to figure out where the overlap is. That would be your combined domain restriction for the whole problem. So if I think about the numerator, if I graph this so I can see this in my brain, here's 0. I am telling you guys that I can use anything from 0 all the way to infinity, right? You guys agree? All right, what is this bottom one telling me? I can use what? I can only use from -2 to +2. Can I include those two or no? No. So where is the overlap? Here, maybe it'll make it easier if I graph. Very good. Where is the overlap that I can use? You guys agree with me that 2 is here, somewhere along there? And then this is the only area from 0 to 2. If you graph it on one number line, you can see it a little better probably, but I just wanted you guys to see it. Let me graph it down here so you can see. All right, here's -infinity, here's +infinity, -2, 0, and 2, right? So in my first, I can use anything from 0 to infinity. My second was anything from -2 to +2, but I can't include those. So where is there an overlap? Do you guys now see where the overlap is? From where? So your domain would be from 0 to 2. Does it include 0? Yes. Does it include 2? That would be your domain restriction. That's hard. I understand that. We're going to work on that a little more. A lot of times you have just one domain restriction, either in the numerator or the denominator. Doesn't always happen where it's in both. And that's hard. You just got to think a little bit. You guys got to look through and say, okay, where is this going to be an issue? Where is this not going to be an issue? Yes?
Why did you put the bracket and like the numerator part, like the 0, instead of a parentheses?
Because the square root of 0 is 0. You can still have that. You just can't, if the 0 was in the denominator, you couldn't have it. But if I, not the 0 itself, the value of the denominator can't be 0. But if I plug in 0 here, then it just becomes 2. So you're good. 4 minus, and then square root. All right, so let me just make up some examples here. Let's do a set of examples, and then I'll give you guys your quizzes back. Okay, so f of x is 7x minus 4. G of x is going to be x squared plus 9. H of x is going to be x squared plus 3x minus 5. Okay, I just made this up. This is how questions will look on your review and on your test. Give you a few functions and say, here, do the following. All right, so pretend number 1 is going to be g plus h of x. Pretend number 2 is going to be okay, all 5 of these questions are different. They're asking you to do different things with the function. They're asking you to evaluate the functions in a different way. I want you guys to see the difference. This is what your questions on your test will look like, on your homework. Number 1 says to do what with G and H? Add them. And your answer should have what in it? An X. It's telling you leave your answer in terms of X. So in order to show me your work and to do this correctly, you would take your G function, because that's the one that's listed first, x squared plus 9, plus your H function, x squared plus 3x, what was it, minus 5? Okay, minus 5. All right, now you're showing me, okay, look, I know which 2 functions I'm talking about. When you are adding 2 functions together, what do we have to do? Combine like terms. That's it. I have 1 x squared here and 1 here. It gives me how many x squareds? 2x squareds. Good. Then I have plus 3x, right? And then what? What's 9 minus 5? Plus 4. So this would be your answer for number 1 example. You added the g and the h function together and left it in terms of x. Does that make sense? All right, let's look at number 2. What do they want me to do with number 2? We're subtracting and leaving our answer how? In terms of x. So my h function, it's important. Order matters when we're subtracting. So x squared plus 3x minus 5 minus, what's the f? 7x minus 4? 7x minus 4. All right, what's something super important we have to do first before we combine like terms here? Distribute that negative. It goes here and here. I don't care how you guys do it. If you want to say plus and then just change your signs here, that's fine. or rewrite it, whatever makes life easier for you. That's fine. Just something to show me that you distributed. So now I have an x squared. I have a 3x minus 7x gives me what? Minus 4x, good. And then a negative 5 and a 4 gives me minus 1. And I know that that is my answer, and I'm leaving it with an x in it because right here it says leave your answer in terms of x. Questions? You guys okay? All right, what's number 3 say to do? Multiply. Which 2? Okay, so x squared plus 9 times, what, f? Okay, good. 7x minus 4. Now, in this case, guys, there's one of two ways you can go. You can go ahead and FOIL. Get x cubed minus 4x squared plus 63x minus 36 combined like terms. Or you could just go ahead and plug in the negative 3 for x, because this is saying plug in negative 3, I want a numerical answer. Whichever you guys prefer is what you can do. If I just say here, negative 3 squared plus 9 times 7 times negative 3 minus 4. That is fine. What is negative 3 squared? 9, and 9 plus 9 is 18, okay? What's 7 times negative 3? Negative 21 minus 4 is? Negative 25, okay. Okay, most of us can't do this in our head. No problem. Just right over here, 25 times 18, right? 8 and 5 is what, 40? 8 times 2 is 16 and 4 is 200. 1 times 5, 1 times 2. You guys with me? So negative 450. Okay. You'll get the same answer if you FOIL this out and then plug in negative 3. It does not matter. But notice, if they tell you to evaluate using a number, you should get a numerical answer. Does that make sense? Do we have any domain restrictions? Is there anything I can't plug in for x when I'm multiplying these two things together? No. Is there anything I can't plug in for x when I'm adding and subtracting these two together? No. Your domain restrictions a lot of times come into play when we're dividing. So let's look at number 4. Number 4 is saying, hey, leave my answer in terms of x. So the f function is 7x minus 4. And my g function is x squared plus 9, right? Can I combine anything here? Can I cancel anything out? Is there anything else I can do? No, this is it. But I do have domain restrictions. God bless you. Look in the numerator first. Is there any number that I cannot plug in for x? Is it okay if you have a negative in your numerator? Yeah. Is it okay if you have a positive in your numerator? Yes. Is it okay if 0 is in your numerator? Yeah. Okay, you're good there. What's the problem with the denominator? You don't want your denominator to become what number? 0. You can use 0, you just don't want it to become 0. So think about, is there anything in the world, thank you, that you cannot use? Anything? What happens if I plug in negative 3? It's going to be 9 and 9 plus 9. Okay, fine. What happens if I plug in negative 973? It's going to be positive, right? So what is my domain here? Negative infinity to positive infinity. Perfect. You can use anything in the world. Now I'm going to change this problem just a bit. Just get us to think a little bit, okay? Just pretend our denominator is x squared minus 9. Now is there a problem? What is it? Can't be what kind of 3? Positive or negative, right? It could be anything in the world but those two numbers. So how would you guys tell me that? 900 million bonus points on nothing. Go ahead. Who can do it? I can use anything in the world but -3 and +3. Parentheses, tell me. Negative infinity. Perfect. -3 to 3. And then 3 to infinity. Woo! Girls, I'm proud of you. Last period, we got the negative infinity to -3, and then we got 3 to infinity, and we're like, what? Guys, think about it. Sometimes it's easy to see domain and domain if we graph it on a number line. I can use any number but -3 and +3, right? I can use anything over here. And I can use anything over here. And I can also use the stuff in the middle. There's just 2 things I can't use. So there has to be a break there. Very good. All right, let's look at the last one. I'll give your quizzes back. G on top. What's G? X squared plus 9. So x squared plus 9 over 7x plus 4. Okay, can I combine anything? Yes or no? No. Can't combine anything. So,
Is it -4?
Is it? Yep. I forgot what I made up. Can I use any number that I want to in the numerator and it's okay? Yeah. Positive, fine. Negative, fine. 0, fine. What can I not use in the denominator? There's something. 4 over 7. Some of you are like, how in the world did she get that? Well, think about it. What can the denominator not be? Cannot be 0. So when you have an expression that doesn't have a square root or anything, you can just say, okay, well, let me set the denominator equal to 0 and figure out what value for x will make that denominator 0. So we add 4 to both sides. We get 7x equals 4. Divide by 7. I get x cannot be 4 over 7. It can be any number in the world except for that. So how would you guys tell me that for my domain? Tell me. Negative infinity to 4 over 7. Perfect. Right there, you just told me I can use anything in the entire world except for 4/7. So with what we talked about today, domain is the most difficult, I think, and you just have to think a little bit. It's not something that right away jumps out at you. There's something factors on the bottom, factor it, set it equal to 0, and then figure out what it can't be. Sound good? All right, good job, guys.